Hi, welcome to Teardown Tuesday. We're going to take a look inside the new Pebble Time smartwatch. And yes, I beat the crap out of this thing at the Tough Bloke Challenge on the weekend. So click here if you haven't watched that video. And the thing actually survived. I took it through all sorts of mud and crap and beat it against all sorts of obstacles, and it survived reasonably well. So let's crack this thing open, see what's inside. You can see that there's still some residual mud on this thing around the buttons there. I couldn't press the button when I actually got out of it. There's a few scratches on the top of the case there, but generally not a big deal. So of course you wouldn't, this thing is only 30 meters water resistant, and that doesn't actually mean it can survive 30 meters down in water. It's just there is like a standard for this sort of thing. It basically means you really shouldn't take this thing swimming. Not designed for continuous immersion, certainly. It's designed for, just splashes and maybe showering and, things general like that. But I beat the crap out of it, and it did survive. I don't know, maybe there's a bit of water penetration in the inside. I don't know. We'll find out when we tear it down. Now, this front bezel is just glued on the front, I believe, so we should be able to maybe heat up that glue and get that front bezel off. So yes, this thing I believe is not hugely repairable if you want to change the battery. And I was surprised that there really wasn't any buildup of gunk inside the contacts there, the charging and the smart band thing, because not only can you charge through this, but you can get add-ons, or you will be able to get add-ons that clip on and then hook onto these two things, and you can have smart accessories and things like that. But anyway, there are no screws on the thing, so if you want to replace the battery, well, you're going to have to open it like I'm about to today, and hopefully we won't destroy it, but yeah, it's not going to be particularly easy. So let's crack this puppy open and see if any water got in, and also see how it's designed and built. Right, so to get this front bezel off, we're going to have to heat up the glue around the front here, and I've got my hot air station here. That's the lowest temperature it goes down to, 100 degrees. That'll do. Got a nice wide nozzle tip on the thing, so I've got various spudgers and stuff. Probably might try one of these. If not, might go to a metal spudger. But the idea is to go around, heat it up, and hopefully we don't do much damage. But you want to just soften the glue on there. I don't know. I don't do this very often, so it's like trial and error. So how much we actually need to heat the thing up by, and just go right around, and well, let's see if we can get anything going there. There's a bit of movement at the station. Yeah, it's getting there. It's prying off. Not sure if you can see that, but yeah, these plastic ones aren't the best. Might have to resort to either a bit more heat or the metal one. There's a lot of glue. That's pretty tough. Jeez. There we go. Got it. Got it. Ta-da! Ha-ha! Beauty. We're in like Flynn. We're in. You can actually see the stainless steel bezel around there, and the top coating, by the way, is PVD, or physical vapor deposition process. So I'm not sure what actual material they've vapor deposited on the front, but it looks bland, but the finish is actually quite reasonable. But as you can see during the torture test, it did scratch up, and you can see the bare stainless steel under that. But anyway, it looks like that's not glue. It looks like they've got like a double-sided tape or something like that. So maybe they've got like a piece like custom cut or something like that, which they whack on some sort of double-sided adhesive tape, perhaps, rather than, it's not like they've gone along with the the hot snot gun and just dabbed a couple of bits of glue around the outside, because this actually determines the waterproofness of this thing, even though it's not waterproof, it's only, it's water resistant, splash proof, things like that. They do seem to have like at least a full seal around there. Of course, you wouldn't survive continuous immersion for a long period of time and eventually seep through, or there could be manufacturing imperfections or whatever. But yeah, it's going to do a reasonable task just for general splashes or wearing in the shower or something like that, and it'd probably do the business. Long-term wise, I don't know what the adhesion properties of all that are, but it looks like it's trying to adhere between the stainless steel and whatever plastic, thermoplastic that they're actually using for the main case here. So apart from the front bezel coming off like this instead of a screw-on back, which is your more traditional watch construction, it is actually fairly typical. We've got the case, and we've got, looks like the entire module inserted in there. We'll be able to lift that out in a minute, and the buttons just push through. We'll see that in more detail in a minute, but then they've just got the contact you can see inside there, just going in there and contacting a little tactile right angle switch on the side of the board there. Looks like that's just going to be the LCD. Aha, that just had a little clip there. The LCD is going to swing open. Oh, and we're more in like Flynn. Look at that. Beautiful. All right, so with the LCD here, it looks like we've got a little PCB mount board to flex connector, so we should be able to just pop that off. Hopefully that's just a press fit connector going down onto the board there, this little surface mount press fit job. Yep, it was. You just get the plastic, of course, under there, and ta-da, yep, little board press fit connector. That's what you'd expect. Got a little bit of tape there over some programming and or test pads. There we go. My guess would be that's maybe a JTAG programming header, perhaps. We've got ourselves about a half watt hour, 150 milliamp hour lithium ion cell in there. There's our vibration motor. So we've got our counterweight down under there. There we go. That's a decent sized job, taking up a fair bit of the envelope in there. But considering that one of the primary uses for a smartwatch is to notify you by way of the vibrator motor or like a beep or the LCD, then definitely they have to give up a lot of room in there for the vibration motor. There you go. You can really see the tactile switches on the side there. Not sure what brand they are, but that's quite a typical design for a watch. They've just reflowed soldered those right angle tack switches on there. There's no like real tactile feedback on that, so yeah, I'm not sure if they're the best quality switch. And of course, as I've mentioned, you wouldn't go pressing these buttons when you're around water, because look at see the different angle I push that at. You can see that there's actually a lot of play in there, in sort of like gap between that button and the case, the plunger and the case. So yeah, but it's not designed for that. Tiny Phillips in there, so we'll whip those out and see what's what, because of course this sucker's going to be a double-sided load, absolutely no doubt. Components on the other side as well. And I thought there was another screw hidden behind there. Yep, there is. That's a another board-to-board interconnect. Ta-da! Now this whole thing should, yep, just pop out. Beautiful. And you can see the charging contacts on the bottom of the case here. They've actually epoxied. Well, that's actually not epoxy. That's some sort of like silicon gel or something. Anyway, these are little pogo pins, of course. Very nice. So they've got those, just the round type, good enough for a one-off pressure thing like this. So, but that's a nice touch. Little pogo pins there. Yeah, they haven't cut corners there. You can actually see the buttons there. You can see that they've put individual circlips around the shaft of each button there. That's rather nice. Attention to detail. Stop and popping back out. That's a quite a nice way to do it. Once again, they haven't really cut corners there. And down near our motor here, you can see this flat flex, which actually connected down on the board down there. There we go. I've got a couple of passives on the underside there. But anyway, there's two big traces. The two big fat ones there are obviously for our vibration motor there. But there's some other stuff. It goes down here, and the flat flex goes along here and over to, once again, another couple of passive parts down there. Plus, I think maybe a little 6-pin, tiny SO-T package, one of those micro packages. Anyway, that'd be the preamplifier for the microphone. So you can actually see the microphone insert in there. My microphone hole, of course, is all gunked up from the Tough Bloke Challenge, but yeah, there's our little microphone element. I'm not sure why it's so far actually back from here. I'm not sure what they got under there, but that's rather interesting. I might take off that clip and see what's what. There we go. I'm not sure what the deal is, but there's our microphone element. They've got a rubber surround on that, so it looks like they're doing some vibration damping there. That's very nice, so you don't get, when it's on your wrist, you move your arm around, you don't want that noise to be coupled through to your microphone, so that's pretty good. Not sure what that block, that solid block in there is doing, maybe just part of the molding or something, maybe, I don't think they've cavity tuned anything, there's not enough room to do anything like that, but anyway, that's a nice little microphone design. I like that. And then you can see we've actually got flat flex coming out from the battery here to these two pads, and you can see that they're these leaf spring surface mount contacts. They're all right. Nothing wrong with that at all. And here's where we can have some fun with our Tagarno microscope. I love this thing. It'll allow us to zoom in up to 40 times on our board here. Ah, fantastic. Look at that. What a Bobby Dazzler. So I know you don't want to see the boring case or the boring LCD, which we'll have a look at shortly, complete with fingerprints on it, but we want our PCB. Fantastic. Now we can go in there and identify some part numbers and have a squiz. Got to take this stupid barcode label off though to get a look. Okay, the first thing we want to take a squiz at here is the memory and the chip. Ta-da! We have a Spansion flash memory. That's 128 megabits, nothing doing there. But here is our main processor spinned around here. It's an ST Micro ST32F439. And that's a pretty grunty little thing for a watch. ARM Cortex M4 with floating point unit, 225 MIPS, and 2 megabytes built-in flash, 256K plus 4K separate RAM. It does crypto. It's got USB on the go. It's got all sorts of things, even 3 ADCs, 20 comms interfaces. Whoa, camera and LCD stuff. Yeah, it does DES encryption, all sorts of stuff. So CRC, random number generators. Bob's your uncle. And a real-time clock as well. We didn't see the 32 kilohertz oscillator in there. Actually, haven't seen that yet. So not entirely sure how they're actually implementing the clock in this thing, whether or not it's a external, the internal RTC, because that would require a separate 32 kilohertz crystal, which I couldn't see on the board. So I guess they must be actually running it off the main processor and in low speed, low power mode, something like that. Anyway, there's the block diagram for those playing along at home. Geez, you can fit a lot in a micro these days. Unbelievable. When I was a boy. And right under the main processor, you can see that puppy there, which looks like maybe an LED, but it's not. It's actually an ambient light sensor. And there's our crystal oscillator there. So, yeah, I don't know about part number on there, or whatever it is. Part number on the ambient light sensor, couldn't tell you. And above the processor and ambient light sensor there, we have ourselves a bare die flip chip. I hope that's not photosensitive. Maybe we can flash it. That might be interesting. It's a CC2564. That one's actually a TI part that's a Bluetooth controller. Let's go to the datasheet. And this is actually a pretty nice chip and quite a common one too, and it does Bluetooth 4.0 and all the bells and whistles. So yeah, they haven't cut corners there at all. Used a nice TI part. Ugh. Uses a horrible, evil dual-layer QFN package. Yuck. And with that ambient light sensor there, with its placement, it's actually under the LCD. So you've got to wonder how it's getting the ambient light, because that's covered with black tape on the bottom. I guess it eventually seeps in through the glass and around and things like that. So I guess it's, good enough to get, is it light or dark? Now, if you're wondering where the Bluetooth antenna is on this puppy, then you're looking at them right here, or at least the contacts for them. Because if we have a look down in there and zoom in, see they've got these little spring contacts there. Oh, I love the Tagarno microscope. Look at that. Oh, beautiful. And the working distance, by the way, is like 300 millimeters. Absolutely incredible. Anyway, that is not the clever part. The clever part is that these mate up to our stainless steel front bezel, and you'll see inside the front bezel that there's actually these little protruding parts up here. So our board sits in there like that and actually makes contact with those points. So the metal front bezel is being used as a Bluetooth antenna. Clever. I'm not sure how optimum it is. It's almost certainly not optimum, but hey, good enough. And there's nothing else particularly interesting on the top there, just the connections. So yeah, it looks like we've got some programming header pins. Probably one of them's got to be like a JTAG interface, and maybe some production test pads as well around here, things like that. Couple more down. Oh no, they just fiducials. They could just be fiducial marks. So here's the other side of the board. We've got a few more active parts on there. Of course, the most interesting looking stuff is happening down here, particularly around there. Let's check those out. Wow, that puppy is interesting. That's a lattice semi LP1K FPGA. What the hell have they got an FPGA in there for? Let's go to the data sheet and see how beastly this thing is, or whether, it could just be a tiny thing used for some glue logic, perhaps. Okay, so that's not much of a beast. It's just one of these very nice lattice low-power devices, 21 microamps standby power consumption. It's got, this is the one we're looking at, the LP1K here. We're only talking about 1280 logic cells, not a huge amount. It's got 64K of RAM, though, built in. It's got a PLL, and, it's got some high current LED drivers. That's interesting. But, yeah, we're only looking at the one of the little QFN, probably that 32-pin QFN package is what we're looking at there. So that just, you can get larger devices, just has different number of IOs. That's pretty much it. Now, I haven't seen anyone mention or any, them advertise that this thing has any sort of user configurable FPGA stuff on board. So presumably it's just used as some system glue logic. On second thought, they could actually be using this as maybe like a little LCD controller. Perhaps. I mean, well, the LCD has its own memory. It retains its own stuff, but I don't know, maybe they're doing some page caching or something, but they've already got that big-ass ARM processor, so, yeah, I don't know. Anyway, they went to a little bit of expense to, an extra $1 or so to add in this FPGA. Actually, it's not particularly cheap at all. I mean, we're looking at $3 a DigiKey for 10,000 quantity. Yeah, they're not buying from DigiKey, but still, it's not going to be far off the mark. It's going to, it's probably going to be costing them $2. And this little puppy, right next to the FPGA, that's a 14690B EWX if you're playing along at home. And for the life of me, I can't find any data on that. But I reckon that's odds on to be a power system controller chip. And this puppy here, which we can see better if we tilt the board, getting to see part numbers is all about the angle. There we go. It's an LDKD564C. And that means absolutely nothing. But being right next to the power terminals here, it's got to be some sort of regulator, and it's, 6-pin package, fairly typical. That's got to be its big output pin. So let's go see if we can find some data on that. Well, it turns out that's a Linear Technology LT3009 LDO, low dropout voltage regulator, and yeah, they don't have the room to put the real part number on there. I think they bloody well could have put 3009 instead of LDKD. There it is. So it's a 3.3 volt job. No surprises whatsoever, because they would be powering that directly from the battery. So that's why they need the low dropout. I'm not sure what that puppy there is. I've had to put a bit of spit on that to bring it out, and that's looks like a little flipped die by the looks of it. JAGTBQ, I don't know, not quite sure. Maybe some sort of regulator, little tiny pissant regulator based on the inductors, or the inductor near it. So maybe some sort of additional regulator power thing to this one over here perhaps, or maybe it's just some ESD protection perhaps for this interface, which isn't just for the charging cable. Of course, it's got that smart strap interface as well. And because we've got an inductor right next to it, two big ass caps there, it's almost like it's some sort of regulator, but not entirely sure. Is that another? That's another similar looking one, but that's a BKJA88. Not quite sure. But once again, see, regulators around there. So that maybe a couple of local regulators, perhaps. And my guess is that puppy, the OOXTY, is the accelerometer in this thing. This is a Bosch BMI 160 IMU, inertial measurement unit, i.e. it's got a triaxial accelerometer and a triaxial gyroscope in it, 16 bits, thank you very much. And that seems to be confirmed by the mark-in code here. You can see that the first letter of the second row is T, and that identifies the BM160. Come on, they could have put BM160 on there. Ridiculous. Anyway, they've got a 3-digit code on top. You know how we had that ODX thing, or 0DX, and that's just a trace code, and well, the L's just for internal use. It's not an engineering sample, because it would have had CC down on the second row. It doesn't. We've got TY. And following on from our accelerometer there, ta-da, this is a dead giveaway, because I know this thing has a magnetometer. It's advertised as such. Then there we go, mag on it, mag 2BT. And that is a very nice Freescale mag 3110 3-axis magnetometer. And I2C interface, no worries. And sensitivity 0.1 microteslas for those playing along at home, and noise 0.25 microteslas RMS. Yeah, I got no feel for it, but it's like half a bee's dick, isn't it? And once again, our marking code confirms the line across the top, the mag, and then they've just got the wafer and date stamp on it. And this thing here, in between the two, I'm coming up short on that one. I'm not sure what that puppy is. Maybe, no, the switches have to be going back to the micro. Wouldn't be some like I/O expansion. You wouldn't need that. So, yeah, not sure what that puppy's doing. It's only surrounded by maybe a bypass cap and two passives, but these resistors could be just the pull-ups for the switches. You'd have to have a look, see where the traces go. So, oh no, hang on the back. Haha, there we go, fooled by the old double-sided load. So we got some larger caps there. Yeah, okay. I think they are some sort of, yeah, something's happening with the switches there. So maybe it is some sort of something for the switches. But anyway, I would have expected the switches to go straight into the micro. And this puppy on the corner here, you might think, well, what's he doing flapping out in the breeze right out there? But as always with teardowns like this, if you flip him over, ta-da, that's the connector that goes off to the vibration motor and microphone board. So we know that the preamp is going to be right up next to the microphone, so it's not a preamp. So what do you need to drive a vibration motor? Well, you of course need a motor driver, and that's exactly what it is, the 2603. And of course, you can't just call it a motor driver. No, this is 2015. You've got to use some wank words. It's a haptic drive with auto resonance detection. Ooh, for linear resonance actuators. Oh, it's a bloody motor driver. Anyway, it's designed to solve common obstacles in driving both linear resonance and eccentric rotating mass haptic elements. Designed for low latency, excellent efficiency, blah, 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 extolling the virtues. I'm sure there are haptic driver aficionados out there who are just getting a little bit moist right now. And as far as the PCB thickness goes, it looks to be bang on 1 millimeter there, based on my little micro ruler. Yeah, I would have expected 0.8. I would have expected maybe 0.5 in this, or even lower to get some more volume space, but I guess they didn't need it. I mean, the watch is already pretty darn thin, so they've done a really good job there, but yeah, they could have made that board thinner, that's for sure. Maybe the reason they didn't make it thinner is, right, they probably didn't need to, unless you needed to get like another half a millimeter on your height or something like that. But not that saving half a millimeter on the size of your board translates into a half a millimeter thinner watch. It's all the systems engineering and how everything else in here fits and, you know, all that sort of jazz. So it's actually a fairly complicated systems engineering problem, this volumetric design, which is one of the aspects of electronics designs I love doing, is, you know, making things fit in volume. It's really a fascinating aspect to design. Anyway, what they did here is maybe they did it because of panelization and things like that. The thinner the board gets, the more warping you get. And it looks like they got at least three tabs there where it was connected into the panel. So, you know, you pick and place. Once it gets too thin, it becomes a pain in the ass for your pick and place machines, especially for double-sided load, where you can't just, you know, whack it onto a flat carrier bed or something like that. So, yeah, maybe they stuck to 1 millimeter for a reason there. And if we have a close look at our LCD display here, no, it's not e-ink, as I incorrectly said in the previous thing. I just have a habit of saying that. It's actually a e-paper display, but it's essentially an LCD which has an individual memory per pixel. And if you go in there, sorry, the color's not the best color rendition. It might show up better in the final edit. Hopefully you can see, there we go, that's better. It's a matter of getting the color at the right angle. You can see the red, green, and the blue lines there fairly clearly. Now, the part number for this LCD display is actually LPM012A220A, and the nearest data sheet we can get, which is basically an equivalent one except a slightly different resolution, is this one from, it's manufactured by Japan Display Inc., and this is a low-temperature polysilicon memory per pixel LCD display. So it actually contains individual memory in there for each individual pixel to turn it off and on for all the RGB elements. And it doesn't look like a SPI interface thing. It looks like it, you know, has its own custom interface, and there is data in here about how to actually drive the thing and stuff like that. There's like the power on sequence and power off and stuff like that. So half Chinese, half English data sheet, so you could actually work with this. Oh, and by the way, on these buttons, I'd bet my bottom dollar that inside there they've actually got a O-ring sealant. It feels like there's a spring in there as well, so that's actually, they've gone to quite a bit of effort to produce that. Don't mind that at all. And if we power it up and display the white time screen, you can see the red, green, and blue in there like that. Hey, is it going to focus? Not quite. About the only thing I'm not really happy about is the fact that, well, you can't change the battery in this thing. Sure, you know, you can, if you've got a heat gun, you can soften up that double-sided gluey tape and take off the front panel, but you're going to ruin the waterproofness if you try and stick the damn thing back on. So yeah, it's certainly not for your average Joe. So yeah, okay, you know, you can at least get in there and fix some stuff, but I would have preferred like a screw-on case back. And by the way, with some of those exposed chip scale packages in there, I thought, yeah, I might be able to kill it by flashing the thing, but no, I can't. So, yep, no problems. So I'm actually fairly impressed by the engineering in this thing. They certainly haven't skimped or cut corners pretty much anywhere. There's a pretty decent use of the 3D envelope inside this thing, and they've done well to get it into that really thin package like that. So yeah, my hats off to the designers at Pebble who've actually done this. They're the real miracle workers. Now, I've actually done a bit of a quick bill of materials breakdown on this based on 1,000 of quantity. And although they've sold, you know, 1 million of these things, I don't know how many they'd be, you know, buying up front. They'd have a lot of purchasing clout anyway. I've just got, you know, 1,000 of quantity pricing around the place, and we're looking at about, you know, for the board, around about 33 bucks maybe. Just for the board, but then we've got assembly, we've got the screen, we've got the motor, we've got the microphone, we've got the battery, we've got the case, we've got the, you know, the front glass and the molding and the buttons and, you know, the little circlips and the O-rings and pogo pins and all the little flat flexes and stuff. So, you know, all up, I'm estimating around about, you know, 55 bucks, something like that, probably for the whole thing. So, you know, it might cost them a bit more than that, I don't know, but they'd have, as I said, a lot of purchasing clout, considering that they've already had, so they claim, 1 million of these things made. So yeah, I think they're making a decent profit margin on it. So I hope you enjoyed that rather lengthy look at the Pebble Time smartwatch inside the thing, and yeah, I still have to glue it back on. What's the best glue to use? I don't know. Leave it in the comments. Maybe some silicone. Maybe I'll just get out the hot snot gun. No, needs something a bit better than that. Anyway, hope you enjoyed that. There's like going to be some high-res teardown photos on EEVblog.com, and as always, if you want to discuss it, jump on over to the EEVblog forum. And as always, if you liked it, please give it a big thumbs up. Catch you next time. Wow, look at that. Unbelievable. Oh, wow. Here we go. Woo! Oh, yeah. There we go. Oh, it's great.